So everybody, welcome to Flux Harmonic. I'm David Wilson, and we're back again today with another live coding stream where we try to build something cool from scratch. And today we're going to be focusing on implementing a basic particle system in the Substratic engine to enable cool effects in the game we've been working on so far called Siphon Break. So thank you all for being here so far. Alejandro and Luis, thanks for showing up. Let's just talk a moment about what it is that we're going to try to do. So if you've played video games, I guess within the last, 15, 20 years, you've probably seen particle effects, which are basically a common feature of game engines where you can create little small particles or a lot of little small particles on the screen to produce certain effects like fire, smoke, explosions, and a lot more things. Rain, could be a lot of things you could do with this. So what we're going to do today is implement a basic particle system in C, which we're going to expose through Mesh to enable the game that we've been working on to add configurable effects anywhere that they're needed. I've got a general design in mind. I don't know how well it's going to work, but we're just going to try to hack through it and see what happens. But basically the idea is that the sort of core primitive is the particle system, which can have one or more particle sources. So for a particular system, you may want to have one particle source for flames. You may want to have one particle source for smoke, etc. If you're trying to do a fire. So you should be able to have multiple sources for particles within one system if necessary. And also, a particle source can have a geometry with an origin relative to the system. So basically, a source can have a place where particles get generated to come from, and it could have sort of a size, basically, where the particle gets generated within some position in that size. Also, a particle source can be configured to control how its particles get generated. So maybe the certain parameters of the particle can be randomized based on, just whenever it gets generated. And there can also be a certain number of particles that are alive at a certain time, that sort of thing. So it gives you the ability to tune the way that the effect looks at runtime. Also, a particle system's origin can be changed every frame to follow game objects, etc. So the idea there is that you would be able to follow a game object. For instance, if you want to have like a particle effect that looks like a booster behind the ship, whenever it's flying, you need to be able to update the origin of that particle system whenever the ship moves around. So that's going to be something pretty key to making all this work. So for the factors of particles themselves, we would definitely have like the number of active particles in a system, or at least for a source, I would say. Also the lifetime of the particle, like how long a given particle should be alive, and that could also be between a minimum and maximum value. So maybe like half a second a particle could be alive, or maybe 3 seconds, who knows. Velocity, so to make the particle move, so it doesn't just sit in the same position after you create it. Sorry, thoughts are coming to my head at the same time. And then particle oscillation on the X or Y axis, or basically particle animation to some degree. So being able to make it so that the particle can kind of moves a little bit. That can be helpful for fire or for explosions or any other kind of effect. So we'll try to add that in as well. And then fading the particle. So maybe you want it to be fully opaque at the beginning and then to fade out as it lives, just so that it has more of an effect like an explosion where you initially see the sparks, but then they fade out as they move. And then we may come up with other ideas for things we can add to this, but we're just going to try to start with these factors at least and see how far we can get. Hello to R Primus. So Alejandro asked a good question. C, why not in Mesh? I suppose there has to be a good reason. Well, I could implement it in Mesh, but I have a feeling that the more particles that show up, the slower the code is going to get. So I wanted to use this as an opportunity to take advantage of one of the supposed benefits of Mesh. It's not really a benefit because pretty much any language has foreign function interface capabilities, but one of the ideas of Mesh is that you should be able to pull in code written in C to interact with it. So for anything that needs to be high performance, you can do it in C instead. So we're going to start with trying to write it in C and see how far we get. But if we end up feeling like it was too difficult to do that, we might go back to just using Mesh for it. Definitely not a GC problem. It's more of just like I suspect that things will get slower the more things we have on screen at any given time. And for a particle system, they don't need to exist like normal objects. They're sort of just graphics that get rendered. So the single object you're dealing with is just the particle system, and you may have multiple particle systems active in Mesh, but then the actual implementation of how those particle systems work and how they get rendered is going to be happening in the C layer. So this could be a bad idea, could be a great idea. I don't know. We're going to find out. And also, Luis says, I've been interested in messing around with StumpWM. I saw your stream around it. Did you give up on it? Yeah, I went back to EXWM, and to be honest with you, I can't remember why. I think that my assumption was that StumpWM was more stable than EXWM, but I had other issues with it that caused it to crash or caused it to have weird problems. So, yeah, I didn't stick with it. I'm kind of like thinking about how I want to proceed with my window management existence going forward. I've been thinking about writing my own window manager, so we'll see if I have time for that. But yeah, that's something that I'm thinking about. All right, so as always, the code for the game project itself is on github.com/fluxharmonic/siphon-break. The CI on there is failing right now. I don't know why, but the builds of the game aren't being produced. But I'll get that fixed probably this weekend sometime, so that you can check out the game and try to run it yourself on Linux. I appreciate Hyder, who actually has been trying to run the game and had some feedback, but I haven't gotten back to that. So Hyder, if you're watching this or you're seeing the recording, thank you for trying that all out. Alejandro says, off-topic, BSPWM is very stable. I haven't actually used that one. I hear good things, but I haven't used it. Okay, so our tasks for today. Try to create the basic particle system in design in C, like what we've been talking about before. Also, make it possible to define particle sources. We need a data structure basically that allows us to say what the parameters for a particle source is. Expose a particle system in Mesh through a simple API with parameters. So probably we need to have a way to say we want a system and we want to add some number of sources along with that, and then have a way to describe those sources in Mesh, probably with keyword parameters. And then add particle effects to a couple of the power-ups that we added last time. So that's going to be the fun part. If we actually get things working to the point where we can show a particle system, then we will try to add them to, let's say, the speed power-up, the energy recharge power-up, and I would like to add it to the item that we made, the heat wave item, so that the enemy ships show that they're burning. But we'll see how far we get with that. Also, make sure particle systems are being garbage collected properly. Since they're going to be native objects, we need to make sure that they get cleaned up whenever they're not needed anymore. We may not get to that, but that's something that I need to do no matter what. So let's get to it. We're basically at the same place where we were last time in the code. I haven't worked on it at all, so we have the same commit. So let me just jump into the Substratic engine code. So we got a lot of stuff here. I'm probably going to want to create a new file called particle.c. And I'm going to include, was it particle.h? I don't know how I'm doing the includes for the local files. Okay, yeah. Fine. Let me grab render.h, just get its little header here, and then put it into particle.h. And we'll change these. Okay, and then endif here. Really need some templates to make this stuff easier. Okay, so I will also grab the init. We'll see, it's like a module init function just to kind of get that started up. The particle module init. So let me see. How do I want to approach this in Mesh? If I go back to main, no. main.msc. Where would I actually put this? I mean, first of all, it would be nice to have a particle system that renders behind the ship, so we sort of see like its booster. It also makes me think that we would need at some point a way to change the parameters of a given particle system while it's running, so that maybe you could make the color change, which I saw also something that I forgot. Oh, siphon break. Did I actually put that the wrong way? Let's see. Siphon break. Yeah, siphon break. If you see right here, github.com/fluxharmonic/siphon-break. Siphon with a Y, which is not the appropriate spelling for that. Particle color. That's going to be interesting because if you want to actually fade the color from one to another, then you're going to have to do some interpolation between two colors, which, you know, is not as straightforward as it might seem. Okay, let's go back to our code for the player. Let's go to the player module, actually, player.msc. So what I would want for a given player, let's see, how would I do this? Probably would want to have like a booster system. I guess I don't need that for the enemy, or sorry, the player, but I do need it for the enemies. So booster particles, let's just call it that. And what I would want that to look like is something like booster particles, make particle system, and then I would have a list of make particle source. So this would be a function that takes a variable number of parameters, like a REST argument, basically. So we could have multiple particle sources. So particle source, let's see. So the origin, we're just going to leave it as 0, 0 to start with. But what we do need is the size. So we could say the size would be, we're going to make this be rectangular at first, but then maybe we'll change it so that we can set different geometries later. So size of 30, I guess. Let's see, vel x. I'm trying to think of how we want to describe this, because we're going to need to do some randomization. So like vel x min could be 0.2, vel x max 1.0. But it would be better if I had maybe even a list here that could be a tuple. So I could do it that way, actually. How about this? So that's like the min and the max together. And then vel y 0.2, 1.0. So we really want it just to go behind. So we don't even want a, so this could be a negative, yeah, okay, so negative 0.2 to 0.2. How about that? Let's try it this way. So what I want is the particles to kind of go out in like a cone shape. So the velocity would be either somewhere between a negative 0.2 to a 0.2, just to give it like, you know, each particle could be going either direction. For velocity y, we want it to be probably all the same velocity. Maybe there could be a little bit of variation. So how about like 0.8 to 1.0? Okay. So then what else do we need? We need a color. And that could be an RGB. Let me just steal the, is it in here, RGB? RGB, no, it's probably still in player, right? RGB. So the heat wave color, I'll steal this color. Where is it? Right here. All right, so we'll just do that for now. What else do we want for that? What were the other factors we were talking about? Oscillation. We'll do that a little bit later. Let's just get a very basic one going first. Particle fade and lifetime. We definitely want that. So is it lifetime or life? Lifetime's good. Okay, so we'll have a range for that as well. So this is going to be in seconds. So if we have it between, let's see, for each, probably like, let's say 0.5 to 0.75, like half a second to 3/4 of a second, maybe something like that. And then what else? Whoops, I'm in the wrong file. Fade, color, oscillation, velocity, lifetime, number of active particles. Okay, so Number of active particles is sort of controlled by the lifetime. So maybe it's not necessary. Oh, what we do need is an interval. So an interval between when new particles are created. So how about 0.2 to, or 0.1 to 0.3, maybe? Maybe that's too much. Okay, let's try that. Okay, so that seems pretty good. So then, do we need anything as a parameter to the particle system? All we really need is the particle sources. And then once we have the system, we can set the origin of the system as things go on. That's interesting. Just thinking about how particles are going to look. Anyway, all right, so then down in the update function, update player, we want to update the particle system. Deplete, move the player, fire the weapon. Then at the end, we can say update the booster particle system. So update particle, well, let's do it this way. Particle system update. And then we give it the player booster particles. What was it? Booster particles, yeah. And then the player object itself. And that should do that. Then I'll steal this line, and then we'll go down to render player and render player effects. Probably we want to render the booster right after that. So let's do this. Particle system render. Render the booster particles. Okay. You know what? I think Alejandro asks, what is the interval? I don't get it. That's actually the creation interval. Make particle source. So I don't know what the right term would be for this, but it's basically the interval between times that a particle gets created in the system. All right. So now, I think this is good. It's a good starting point. We also eventually need a sprite, like some texture that gets displayed, and that texture could also be animated at some point, but we'll deal with that later. Right now, we're just going to be drawing rectangles as usual because we don't have a way to draw any other shape. And I mean, I could draw a circle in the GIMP and put it in, but let's just get this working first. So we have this little snippet here, and what I can do next is go into the Substratic module, Deps, Substratic, Engine, Modules, Substratic. So what are we pluralizing the name? No. Particle.msc. Like time deltas? Yeah, basically. So define module substratic particle. I don't know if this should go under renderer, but we'll go with this for now. Imports, we won't deal with that just yet. I'm not going to copy this in directly. I'm just going to paste it in as an example because I need to write some wrapper functions here, I think. Because I don't want the C layer to have to deal with processing the keyword parameters. That's something I can add later in Mesh so that the C layer can actually define what keyword parameters that it accepts, but for now we don't have that. So, define make particle system. You know, that could actually be a C function because you have access to every possible parameter to a function. So we don't really need this to be a function yet, but we do need make particle source. And keys of size, color, interval. Wow, that's so loud. Vel X, vel Y. Okay. And then what we're really going to do here, thank you Cyborg085 for following. We're going to call make particle source internal, and we're just going to pass those things right through. And we do want those intervals to be passed through directly, the sort of the ranges we have here, because those are going to be used to generate a random value between those two numbers every time a particle gets created. So that information is needed long term. Okay, so size, color, interval, lifetime. vel x, vel y. Okay. Interval probably needs to be renamed, but we'll do that later. Got to let the design bake a little bit first. Okay, so now we can go into the C functionality, particle.c. We can create a function. Well, actually, we need to go back into renderer for a second. We need to get the module init function here. Just copy this over so we don't have to remember how to do that. Subst particle module init, substratic particle. There we go. We also need to pull in mesh.h. Whoa. Okay. Let me just put some space between those so they don't try to get reorganized. Okay, and then I'll delete all of these and then add in the make particle source internal function. This is not, well, should it be exported? No. Not exported because we don't want that to be public. And then subst particle make system source. No, source. We also do need the make system function too, and that's going to be written directly in C. So let's copy this bit. I don't know why I just code formatted it like that. Whatever. Okay, so make particle system. And this one definitely needs to be exported, so we're going to say true here. Make particle source, make particle system. All right. So now we can make those functions. Let me go back to renderer once more and copy this. I really need some templates for even this part. I think someone suggested that last time, and I just haven't had time to put it together. All right, let's just take off everything here. Subst particle, what is it? Make particle system. I know it seems redundant with the naming, but it's because subst particle is sort of like the module naming convention. Doesn't get exposed to the user anyway. I guess, you know, let's just do it like this. Subst particle make system, subst particle make source. Just so it's not so verbose. Okay, so we're gonna do, let's start this off easy, t val, and then make source. Okay, there we go. Great, so now read in and process every snippet. Yeah, it needs snippet or temple or something like that for sure. Read in and process every source argument, particle source argument. We're also going to need functions for updating and rendering, right? So if I go back to the code that I wrote in player, I have particle system update and render. So let me just pull those. Ooh, I need to actually update. There's two things I need here. First of all, I needed the time delta. And then in particle system render, I need the renderer as the first parameter, I believe. Renderer. Okay. And that should be good enough. So let's go now into particle.c. We can also add some functions for the other two functions we need. So here, particle system update. Okay. And then particle system render. All right, so we're just sketching this stuff out here. And then we can copy that line, particle system update, particle system update, and then render, same thing. Render. Render. Okay. So we've got all the functions we need right now to interface with mesh. So let's think about how we want to describe all of this. I think for now we don't really need to put this in a header file because we're not going to export the C library to anything. So we can just make some structs right here in this file until we decide we need them elsewhere. Okay, we'll type def struct. Subst particle system. And then we can have subst particle sources. Maybe that should just be a pointer. And then type def struct subst particle source. Now, question is, do we need another thing like type def struct subst particle factor, there we go. And that would be like a float min, float max kind of situation. So each of, let's see. Yeah. So each source would have something like, let's say, subst particle factor. And velocity x, right? So something like that. Velocity y. That way we can describe what the minimum and maximum values are for each of the various factors at play here. We may need different types of factors as well. Like let's say a float factor or a color factor or things like that. Then we also need the lifetime, the interval. We need a color. How do I represent color in Substratic? Let's see, in source renderer.h, color, subst color. Okay, so we need to pull in the renderer file. So include renderer.h. So we also need a subst color. And I think that could just be a regular struct. We don't need it to be a pointer or anything. What else, excuse me, do we have? Let's go back to particle.msc. So we have size, which is going to be a regular float, I think. So float size. However, we do need to have the size for the individual particles, because some particles could be bigger than others. So that's actually something we need to think about. So in fact, we could do this. So it's a different type of size we're thinking of here. So size could also be a min and max value. Geometry. And I think that we may need to come up with a way to describe the geometry. That could just be like a make particle source geometry or make particle geometry function as well. And you could say what the size would be and whether it's like a circle or a rectangle, maybe. I don't know. All right. Make particle source, keys, geometry, etc., etc. All right, so now let's go back into player.msc. Let's change. Is that the right file? Yeah, okay. Size. Now this is going to be different. So for each particle, we want the size to be, let's say, maybe like 7 to 10 pixels. So 7 to 10. How about that? And then geometry, we're just going to make this be a number for now. So geometry, I think I made that with 30 before. So we're going to put a number in, then we can change it to be like an actual struct type later. Okay. So it's geometry, size, color, blah, blah, blah. Good. So now we can go into particle.c into make source. I'm going to paste this line in, comment it out so we can see the parameter order that we're looking for. And we basically just need to go through all of the arguments and double check them. So let me see, arg count. I want to pull in an existing check for argument count. We have 1, 2, 3, 4, 5, 6, 7 arguments right now. So we're just put here, function requires 7 parameters. And then we can just start picking them off. So something like, all right, so as something, so as consts, we're probably going to pull for some things. Now, geometry, we'll say as number first, I think. That's a double, actually, but we'll just go with this. So we want to malloc a system for this. So we're going to have subst particle source equals malloc size of subst particle source. And then we can say source, I need geometry, float geometry. Did the stream fall? No. Weird. Had a glitch on my other screen. Okay, so let's just call it that for now. We'll get back to it and fix it later. So source geometry as number args, I think it's going to be 0 here. Then source, what's next? Size. Yeah, size as number args1. Now we're going to take another approach on this one. We're going to have to come up with a function for this. And it's going to set a subst particle factor. So void subst, or let's see, read particle factor, subst particle factor. Also need the, let's see, value args int index. All right, so this is what we're going to do. We're going to look at the index and see if it's a const. So here we'll actually do read particle factor ampersand source arrow size args, and then the index we expect is 1. Okay. Then we could basically just do the same thing for a few of the other parameters. So color we can't do that with, but we can do it with interval, lifetime. This would be 3 because it's not 2. Vel X and vel Y. Having some thoughts here. So this would be 5. And this would be vel Y, and it would be, oh no, actually, interesting. I actually need to int next index equals 3. Check this out. And next index. So I think I'm going to have to make this an updatable parameter so that based on whether it's a single integer or a range, we update the index accordingly. Okay, so this read particle factor function will actually update the index as it goes. All right, so that's good. We've got that. Uh-oh. Actually, maybe I should move the color parameter so that it doesn't get in the way. So geometry color size. Let me go back here and change the order in particle. So I'm going to change this so that color comes before size, and then all of the factor-based parameters can be more easily accessible. I guess it doesn't matter too much, but you know, better to know for sure. Okay, now for reading the color, we're just going to skip that one. So next index, so we say args1, and then number 3. Let's see, so this would be 0, 1, 2. So this is going to be 2. And size, we're going to put size here. So next index. Okay, so that looks good. So now we can just sort of set the color to begin with. So source, update source size. Did I do that wrong? Let's see, source color dot. Did I not? Okay, yeah, thanks. A little bit of stream delay. Okay, color.r. Let's just make it red to start with. I mean, I guess I could pull the color value. How about that? Let's just do that. So it's going to be an object pointer. So as pointer args1. And we need to get the actual pointer value out of it. We need to cast that to a subst color pointer. So once we do that, it should be able to... Oh, we need to dereference the pointer, right? Maybe it's fine. We'll see if it gives me a compiler error when I try to do that. All right, so geometry, color, and then everything else here. So I just need to implement this part. Okay, so the plan here is to check what type of value is at the given index. So I can say args, and then dereference the index. Value min equals. Try that to start with. So then we could say is const min if is const min. Then treat this as a range. Else, well, we should probably say else if is number min. Then treat this as a single value. Either way, what we'll do here is factor min is going to be as number min, and then factor max is just going to be the same as factor min. Let's just take factor min. Okay. Use of undeclared variable. Well, I did it right here, right? Okay. Cool. So in this case, we want to say index plus plus, I think. Yeah. Update the index so that the next read comes from the right place. Okay. So then what we'll do here is just copy that as number min, and then as number, I guess I could do, yeah, why not just do that? Put this first. Whoops. Then I can sort of just copy what I did here. Drop that right in. Okay. As number min, as number args index, which is going to be the next value, and then that should do it. Hopefully. We'll see. Okay. So then we have the source. Interesting. I need to think about this for a second. Yeah. We might need to have something like a preliminary period where you sort of generate some particles for some period of time and then start rendering from that point, just to sort of queue it up. But we'll think about that later as we see how everything looks. Also, maybe a duration would be helpful too, but we'll look at that in a moment. Because we got everything for setting up a source. Now for creating a system, all we really need is to do a similar thing where we malloc. Well, hold on. Let me. Yeah, I need to do this. So, was it as object val mesh object make pointer mem, and then the source itself. Let me just check that. Mesh object make pointer. Okay, true. I see. No need to update the index. No, at that point, That's actually a good point. Yeah, I think I do. You're right. Thanks, Alejandro. Okay, so I'll do that after I finish what I'm doing here. Yep. You're right. Okay, so source true. We're gonna make it managed so that garbage collector takes care of that. We'll see if it works. I think it will work, actually. It'll be fine. Yes, actually, it will be great. Okay, so I need to go back up here, as Alejandro mentioned. I could probably do this and then drop that here again. A little bit lame. Or maybe I could just, let's just make this a little bit more reasonable to look at so it's not so freaky. Then here I can say plus equals 2. No. Yes, right, because we're saving the value in this case. Okay. All right, same thing up here for making the system right here. Yes, exactly. I think it's, I prefer to have things less clever and more readable, just mainly to make it so it's easier not to make a mistake. Or let's say harder to make a mistake. All right, so mesh object make pointer mem source. All right, we need to have a system here as well. So let me go and just copy what I did there. Whoa, where did I go? Okay, so we're gonna do a system here. Okay. Subs particle system. Great. And then we just need to hold on to the list of yeah. We have to allocate an array here, which is not the greatest thing to have to do. But that's okay. I'm not that worried about it right now. So for system sources, I can say malloc size of pointer of subst particle source times arg count, because it's just the number of arguments. And then for int I equals 0, I is less than arg count, I plus plus. Then system sources I equals, and we just need to unwrap the pointer. So subst particle source as pointer args I pointer. And that should do it. Then that will store all of our, whoops, I need to update this. That will store all of our sources that we pass into the function. Because we've already created them by calling that other function. So we've already gone through this make source function and we've returned the object from mesh. So that's great. Now we need to deal with updating the particle system. Excuse me. So actually, each source is going to need some state in addition to the factors that are there. So source configuration and then source state. And I don't know if those would be separate structs, but we'll start with just one struct for now. So we can have a float of current time, which gets updated each frame. Basically just add the time delta into that. We probably also need the list of current particles. That's going to be another thing we're going to have to manage. So subst particle, excuse me. Subst particle. And this is going to have its own set of state. So it's going to have things like, let's say, position X, position y. Can I just do this with commas so it's not so verbose? Okay, so then vel x, vel y. Let's see. Float current time or lifetime, I suppose. Float lifetime. Because we're going to choose that lifetime value based on the range in this particle factor. Current time, lifetime, size we're going to need also. So float size. And that's pretty much it for now. The color also we will need. Maybe I'll just copy it over, because eventually we will make that be separate. So the current time and then the subst particle pointers to particles. Now, it would be nice if we could have like a statically allocated array with a limit, I guess. I guess a predefined or a known limit, let's say, for how many particles could be active. Because I don't want to have to be resizing an array at runtime. I could do it, but I'm not really interested in doing it. If I say that there's a maximum number of particles, I would have to replace the oldest one. Which is not a problem, to be honest. So, if I say something like int oldest particle, int num particles, then you can sort of have a like a circular buffer almost of particles where array is allocated to fixed size. Each new particle increments num particles. When num particles, we also need max particles, is equal to max particles, replace oldest particle. Yeah. And then basically do that. Now, we have to deal with lifetime too. Which is probably not a problem, actually. I'm thinking like, if there's a lifetime and older particles are sort of dead by some point, we don't update them anymore. But we can still use the same logic to replace the old ones, I think. So maybe we also need a bool is alive. Something like that. So that could work. So then if we are going to make it have a max size or a known max size, I think that we need to have this set up. It needs to be with, whoa, no. Yeah, the source is the one that is going to have that. Okay. So max particles. Or can I say maybe just limit? Particle limit. What if instead of lifetime and is alive, you put there a time to die? Yeah, I mean, I could use lifetime for the same thing, but problem is, okay, time to die. I see what you're saying. So you're going backwards and you just check time to die. That's not a bad idea. Because then you only have one variable you have to check. And it's easy to tell whether it's alive or not. Okay, I like that. Thanks, Alejandro. So we can go back into particle.c. Is alive. Time remaining, I guess. Or time left, let's say. Time left. Okay. current time and time left. This will also be, if this is 0. Okay. That's cool. So num particles, max particles, oldest particle. All right, so we have a few different things we have to start dealing with now. Also, for the source, I will have to go make source. I need to go set up that, that array. Also need to take that parameter we just added. So the particle limit. I don't like calling it particle limit. It's better if it's just limit, but limit's kind of vague. Limit? What does limit mean? I guess max particles just sounds better. We'll just go with that. I mean, that's what it says in the code too, so it's not so bad. Okay, so geometry, max particles. Max particles is also a configuration feature. So max particles, let's just take that out here. We're gonna go put this right over here. Int max particles, okay. Cool, and then num particles, oldest particle, good. If you put time left, you need to update the structure, but if you put time to die, you just need to check if that time has already passed to know it's already dead. That's the same thing though, right? It's basically this, I mean, it's a different name, but the same concept, unless I'm missing something. Okay, so when we create the source, we need to read in the max particles. Let me update this little thing I have here. Max particles, and then color size will drop to the next line. Just right here at the same position. Boom. Okay. So then we need to read another integer. So let's actually bump this ahead to 3. We'll say max particles. Max particles ought to be the first one, to be honest. So how about I just change the order of these? And I will move this up 1. All right. So then max particles is 0. Geometry is 1. Color is 2. And then this is 3. Okay. That looks good. So now we have max particles, but we also need to allocate the particle array. And that's going to be source particles equals malloc size of subst particle times source max particles. Okay. So now we've got our array, but we also need to initialize the state for that as well. Num particles is 0. Source current time equals 0. Our count needs an update. Ah, yes, thank you very much. So there's going to be one more, right? So we got 8 now. Let me just double check. 1, 2, 3, 4, 5, 6, 7, 8. Good. Pair programming with Alejandro here. So read in particle configuration factors. Create the particle source. All right. I think that's good. So now we just need to write the functions to update and render these. So then system update. Now, has the interval passed? Now, probably also need some state for next interval. Int next particle time. How about that? Oh, not int, float. Now let's put this right here. Okay, so current time, then next particle time. So then update function. All right, so if current time is greater than or equal to Source, still need source. All right, so I need two things here. First of all, for each source, I need to update this. Okay, so first I need to grab the, let me just steal that really quick. Grab the system that's being passed in. So subst particle system equals subst particle system as pointer. Args is 0. And then also we need the, this is a double really. Time delta equals as number args 1. Okay, so we got both of these now. Subst particle system as pointer, blah, 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 good. And then for each source, so do we have a list, or sorry, the number of sources? I don't think I'm storing that, am I? Okay. So then we need an int num sources. Then we make the system. We need to store that number as well. System num sources equals arg count. Okay, so we got that now. All right, so source current time. Oh, actually, we need to do the for loop. For int I equals 0, I is less than source system num sources. Okay, I plus plus. Then do this inside. So then source next particle time. Okay, so at the end, decide the time for the next particle. We need to say source next particle time equals source current time plus, and then we need to get the factor here somehow. All right, so also I need to do this first. Update the current time for the source. In fact, we got to do that inside here. I wonder if the system just has a current time and you don't need to store it for all the sources. That's probably a better way to do it, because the sources aren't going to independently operate. They're all operating based on the system itself. So let's do that for the system. System current time plus equals time delta. Okay. Update each of the sources. Let's go back to the struct for, we need that on particle, but we also need to go down to source state, delete current time, and then put it over here. All right. So if the interval is passed, system current time is greater than source next particle time, then we decide the next particle. So we're going to need a function for that. So let's say double particle factor next value. Let's call it something like that. Then subst particle factor, maybe that's a pointer. And that's pretty much it, I think. We just need to do a rand effectively between the two values. So then we need to return. Now I need to remember how I'm doing that. Rand, no. I think it's in mesh math. Let's go look at mesh. Deps, mesh, compiler, source, math, rand. There's a rand function for okay, C random double. There's a function for this. It's like GC something. Oh, right. Okay. Yeah. That's actually a good way to do it. It's basically, see, range, max minus min max, rand max divided by range. Is that right? Yeah, it doesn't cover the full range of precision. So, yeah, the way to do this here, I think this is the way to do this. Okay, so we have the min and max value. So double range equals factor max minus factor min. Maybe I can pre-calculate that too, so I don't have to do it every frame. And then rand modulus with 100. Then double val equals rand modulus of 100 divided by 100.0, or double 100 effectively. That gives you a 0 to 1 value, I think. Yeah, 0 to 1 value. Then you just multiply range times val plus factor min. This should group correctly, but I'm just going to do it anyway because I'm feeling skeptical. So I think that's the right way to do that. So you take the range of possible values, you get a 0 to 1 value using normal rand, then you multiply that 0 to 1 value times the range and add it to the base value to get the value in the range. Okay. So particle factor next value, I do need to set up a random seed as well. So probably should figure out where I'm going to do that, but I'm not going to worry about that just yet. Particle factor next value, we can use that right here. Particle factor next value, and I want to pass the source interval, right? Okay, so that's the next particle time when the next particle will be created. So create the next particle, or the new particle. How about that? Or it's not really even creating, it's like initializing. It'll initialize a new particle. Okay. Now, we also want to update all existing particles. So for int j equals 0, j is less than system num particles. And then j++. But we also need to factor in the oldest particle index when looping. So I have oldest particle, right? Oldest particle, so num particles. I also need to set oldest particle here, obviously. Oldest particle. I need to take that source out. But back in the creation of this, I need to initialize current time, system current time. Okay. There we go. So then, I know we're going a long time without trying to run the code, but we kind of need to get to this point before anything will be visible. I think we're making progress, though. We're doing pretty good. So factor in the oldest particle when looping. Maybe... All right, let's do this first. Initialize the new particle. So oldest particle. Well, we're always going to place it where the oldest particle is. Or not, because we have num particles. If okay, so like we were saying in this little logic that I wrote out up here, let's just take that, move it back down here. Just drop that below. We'll put that right there. Okay. So allocated to fixed size, each new particle increments num particles. So if num particles is less than source max particles. Then source num particles plus plus. And then we return, let's see, subst particle equals null. Then we can say particle equals source particles source num particles. Actually, let's do this. We're going to have to do some math on this. Hey, Fade. Because this is not going to work perfectly, but at first. But we'll figure it out. So then we take the index of num particles as the particle index. And then we increment num particles. Otherwise, if source is num particles is equal to max particles, then we need to do something different. We're going to say particle equals source particles source oldest particle. And then we could say, because we're consuming the oldest particle at this point. So then we can say source oldest particle. And then we're not going to change num particles because that is going to stay stable. But then for things like this, we're going to have to factor in the oldest particle position. So we'll deal with that in a second. So to do factor in oldest particle index. All right. So we initialize new particle. Then we also need to do, we need to set the other factors for it. So set particle factors. Source. No. Particle. Let's just say vel x. This is a lot of stuff here we got to do. Vel x equals, and we got that function here, particle factor next value. We'll just pop this in right there. Source vel x. Is that right? So we have vel x, vel y. Okay, cool. So let's just do the same thing here. Vel y, vel y. And then pos x and pos y. Maybe we do need like a value range for the possible x and y positions. I have to think about that for a minute. All right, excuse me. All right, so we might need it. Okay, one other thing I forgot is that for the system, we're going to need a float pos x and pos y because we're going to need to be able to move it around. And that comes into play here where the position x and position y need to be offset by the system position. Size. Let me think about this. Yeah. Okay. So we'll say size here. Let's just say size for now, and we'll fix it later. And then, and why am I doing an ampersand? Oh, I just need to pass the reference. I don't want to do a value copy. Okay, so pos x is system pos x. And we're doing this at the time the particle is created so that whenever you are moving, your particles don't move with you. They stay where they started. So it leaves a trail behind, basically. Okay, so then vel x, vel y, that all looks good. What other factors do we have that we need to take into account? Interval, we already taken lifetime and size. Okay, so lifetime is something. We also need to copy the color across. Cool. All right, so lifetime, we'll say particle I should also add an underscore, I think. Is subs color RGBA? Yes, it is. I haven't factored in fading yet. I need to do that in a moment. Source, lifetime. Okay, lifetime, particle factor next value, lifetime. Particle color equals source color. All right. To do. Interpolate colors. Okay, so that sets up the particle, which means it will be alive. Now, particle, we also need to do this time left equals particle lifetime, so that we can say that the particle has a certain amount of time left to live. And I think that's it for initializing a particle, at least for now. So then updating all existing particles, we basically just need to let's say we have a particle. And we've assigned it somehow. So update velocity. And then also update lifetime. Actually, we don't need the lifetime variable. I already took that out. Current time and time left. Okay, so I need to go back to particle arrow, and then it's not lifetime, but it is current time. And current time is going to be 0. Now let me think about that. Do I need current time either? No, I don't. Just time left, because I can subtract the time delta from time left, and that's it. Okay, so that's even better. Simplifies things. So size we also need. Oh, size is a different thing. Crap, okay. So what I'm doing here is a little bit wrong. Let me do this. Size. I'm not going to put the POSX in there. I could probably just move size down here next to color. That's fine. This needs to be different. So trying to think of the right way to approach this. So right now I have a single value called geometry, which is a terrible name. The easiest way to accomplish this would just be to say plus rand mod source geometry. And I think that would do it. Is size going to change? It's a good question. It probably should at some point. But for now, it won't. Why is it factored? Just so that you can have a size that... Yeah, size will change based on the range of possible sizes for the particle at creation time. So I'm going to put this rand right there as well. And that will give us... position X, position Y based on the geometry, which is basically just a width on both of the axes. Just very primitive. We'll fix it later. Okay, so that gives us all of the factors we want, I think. Time left equals particle lifetime. The next particle time. Okay, so now update lifetime. So particle time left minus equals, or actually equals max of 0.0 and particle time left minus time delta. So if particle time left is greater than 0, then we'll just continue updating everything else. Otherwise, just ignore it. Actually, okay, we'll do this. We will put this here to say if the particle is dead, just leave it alone. In fact, we may not even have to. How about that? Let's just leave it where it is. Okay, so update velocity, particle, update position equals particle vel x times time delta. And then same thing for y. Whoops, I made a little mistake here. Okay, Why is it indented like that? Okay. That's all we really need at this point is the position. We're not going to change the size over time. We will need to fade it out. So to do add fade. That should work, I think. Return t-val. Okay, that's fine. I'll just return a true on that. Now, the thing I said is that in these two places, we need to calculate the right index based on the oldest particle index. Why use max? If it is less than equal to 0, it will not update. Yeah, if it's less than equal to 0, I don't want it to update because it basically means it's dead at that point, right? Yeah, I guess you're right. Maybe less of a call. That's fine. I was thinking that the equal to 0 would be faster, but maybe not. Maybe it's the same. So let's just do it like that. So it's less than or equal to 0. I definitely appreciate all these ideas and feedbacks. Okay, so time left is time left. Oh, we can just change this to be just a minus equal in this case. Okay. All right. So now let's see if we can render them, huh? So for each system, or for each source, let's say. So we got to get the system first. Oh, no, actually the renderer, subst renderer. The comparison was right, was it? Ah, you're right, it is right. Thank you. Where was it? Subst renderer. Renderer equals, and then I'll copy that a little bit, paste it in there. Okay. How is that there? All right. So args0, args1. Need to change this to subst renderer. Cool. Take out the double time, the delta time. Take this out. Render each of the sources. Okay. Put the t-val back outside. All right, so system num sources, render each of the particles for int j equals 0, j. Now, if I was doing this highly efficiently, I would probably do it with some kind of instance. In fact, yeah, using OpenGL to do this more efficiently will be something I need to do at some point. So how about this? To do, use OpenGL instanced arrays for this instead. I think that's what it's called, instanced arrays. All right. Because you're basically just manipulating memory directly on the graphics card at that point. System, source, no. System sources of I, particles, right? No. Num particles, j++. Okay. So then we need to do the proper looping. But let's just assume for now that we're just going to be very naive. What am I looking for? Particle. Subst particle. Where did I say particle before? There's a couple places up here where I did the wrong thing, I think. No, probably not. Particle equals system sources I, particles j, to do offset based on oldest particle. I'm avoiding that for now, but I'll go back to it. And now that I have the particle, then I can render a rectangle. So render rect, or is it draw rect? Draw rect fill. SHA fly keys. I'm not using SHA fly keys. Or XA. However you're supposed to pronounce it. Okay, so we got the color. But also hello to you, Celtic Orthodox prayer. Render, draw, rect, fill. So we got the renderer, we have the X, Y, width, height. Yeah, we got size we got to deal with. All right, so we'll do it that way. So it's called UR. Okay, gotcha. So we have our renderer. We also have the particle pos X. I'm gonna fix my little mess here. Okay, we got the Y as well. Also particle size, right? Particle size, if I'm not mistaken. Particle color. And I believe that will do it. Yeah, particle size, position X, Y, and then color. Okay, so in theory, this would render something. Whether it will or not is another story. So I think it was time for us to try to run this thing after all this code we blindly have written. Now we're going to see how many times we're going to have to run through the compiler. Undefined variable make particle system. All right, so I got something missing here. Oh, okay. And the substratic lib.c, I need to include the particle module. Hello, Schmelliork. Yes, we're working on a particle system right now. So particle, did I call it particle? Yeah, particle.h. Here we go. Try it again. Undefined reference to subst particle module init. Oh, that's a bunch of BS. So let me see. What did I do wrong here? Particle.h, subst particle h, subst particle module init. The compiler or interpreter is the third best friend of a programmer. Yes. Yeah, it's going to tell me everything that I did wrong now. All right, so in function, this is a linker error. Subst library init. Oh, okay. I forgot in the project.msc to add that file. So we're going to need to add in particle.c. Schmelliork says, made a particle system using C#, monogame, and a custom library that allows coroutines. Cool. Not made in Unity. Many solutions make particles. Yeah, for sure. Okay. Good. We're now getting syntax errors, which is a good sign. Particle line 41. Okay, source, right? What else we got? Assignment to int. Feel free to ask any questions, Celtic. I can multitask. All right, assignment to int from subs particle source makes integer from pointer without a cast. All right, it's 53. But do I just need to wrap this? Sources whoa, hold on. Oh, that's correct. Yeah, that's right. Take a look at this. Incompatible types when assigning to type subs. Oh. It can't copy? Oh, I need to dereference, of course. Wall of errors. Passing argument 1 of mesh. What's what? VM? Let's see. Object. I don't have that one open. Let's go into mesh, compiler, source, obj. And make pointer. Okay, it wants VM. Fine. Whatever. So go back to particle and then make pointer. Anywhere we call make pointer, we need to cast to VM, which is terrible. I need to fix that. I think there's only these two places. All right. Incompatible types from assigning to type subs color. I think it's another place where I need to dereference. So line 86. Just dereference this to do a value assignment or value copy. Oldest particles. Oldest particles. This is oldest particle. Thank you, compiler, for telling me that. Got that one fixed already. Source undeclared. Particle.c 127. Now, source next particle time. I'm not actually saving that. Yeah, so this is the problem here. System sources of I. Where else am I doing that? Few places. Okay, so maybe I should just actually save that as a variable so that we don't have this problem. Subst particle source equals. All right. We're going to say source there, and then we got it. Let's do that. Code cleanliness. Particle has no member lifetime. Yes, you're right. I don't have that. Ooh, what did I have there before? Yeah, let's do that. Particle factor next value, and that's going to come from source lifetime. And then do that. Okay. Invalid type of argument. Let's just compile it again. See where we're at. And GNU Geeks, can I expand a hard drive to include a properly formatted USB drive? I don't know the answer to that question, unfortunately. Okay. So 127. Incompatible types when initializing type particle source from particle. What? Okay, guess that's what that is. Yeah, maybe it's a pointer. That's right. Okay, yep. Same thing. 133. Source particles. Yeah, okay, fine. Let's do that. Yeah, this is going to be a problem. So I think I should probably fake it for now, like I did here. So let me just go back and drop this in here, because this is going to crash us immediately. Source particles, J. All right, we're getting there. So 141. Invalid operands to binary have int and float. Okay. I got to do this fancy little trick again. All right. I need a function for this then, apparently. Or potentially... Yeah, okay, so double, rand double. Double min... Oh. Actually, I have it as floats. Whatever. Double max. And then we will just basically take this. Max minus min. Plus min. Okay, and then this would just be rand double of factor min and factor max. Probably should change those to doubles too. I'm going to return that. Okay, so now, where was I? Line 141. So rand double of 0.0 to source geometry. All right. Let's see, 151. Particle factor next value has no member current time. I think I fixed that. No member name num particles. Doesn't? No, wait. The source. And then 185. Okay, let's just build it again. Damn pointers indeed. That's okay. We're almost done. Subsparticle has no member name, current time. 155. Is that initialization? No. Next particle time is system current time. I changed that. Also 189. System sources num particles. Invalid type argument of arrow. Okay, so I just need to put a dot there instead. That seems wrong. Oops. Incompatible type for argument 6, 194. I probably need to do a cast there, don't I? What am I doing in renderer? Because I take in a subst color. Cast it to float. All right, cool. That's fine. Let's just steal that. Go put it back here and right there. Let's see if this works. Nope. 194 again. Same place. Cannot convert to a pointer type. Why not? It's already a pointer. Oh, I need to do the ampersand. All right, crash. Undefined variable make particle system. I think I need to go into player and import substratic particle. Let's okay. Undefined variable make particle source. Did I see the same error just then? Make particle source. Substratic particle. Particle.msc, substratic particle. It's not the first time I've defined a module, though, because I've got all of these. And render as well. Yeah, so this should work. Nothing should stop this from working. Substratic particle. Substratic renderer. Oh, hold on. Haha. I did not actually export this function, so that would explain why we're having trouble here. Okay. At least we got a crash now. That shows we've gone somewhere. Make system. Particle.c line 53. So, what did I do wrong? It's already a pointer. Maybe the compiler complained at me when I tried to do that, didn't it? Sources I. Sources is a pointer. And then whenever I use an array indexer, so okay, something is this is an array of pointers, so I think I need to right, this doesn't make sense. I want the address. Let's try that again. Did it hold on. Did it complain in the compiler? I think it may have complained. Incompatible types. Assigning to type subst particle source from that can't be right. Ah. Maybe. Oh, okay. Wait. Hold on. That's wrong. That's wrong. What I've done is not create a array of pointers. I've created an array of instances, effectively, of subst particle source. Can I just copy that? No, I don't want to copy that. I want to have the actual pointer. So then, in that case, I need a pointer. That's a lot of fun. Because each of the items needs to be a pointer to a source. Because I already have them. So let's go back to, let's see, malloc. Sources. Subs particle source pointer times arg count. Okay, so that's right. Now the question is, did I do things wrong elsewhere? So this should now be okay, but if I say arrow sources, yeah, this now can go away. 2 stars Michelin C code. Yes, indeed. So anyway, we're do sources. Let's see. Let's change that from a dot. Yeah, now I see what I did wrong. That was confusing me before, and now I see I was doing something stupid. Okay, everything looks right now. Okay, let's try this. All right, so the code launches. Oh, then when I try to run it, nice little crash. Okay, so heap buffer overflow again. Okay, this is an update. That makes sense. So particle C, line 145. Particle position X. So we've set particle. Source particles. Num particles. So this has been initialized. I mean, it's been allocated at least. So num particles. Maybe I should print some things out here to start with. So printf num particles is source num particles. Oh, I don't have a max particle value. Do I? Did I put that in the code? Player to MSC. Make particle system. No, I did not. So that's probably why. I need an error when I don't actually pass in the max particles. Max particles, let's say 20. I don't know how many we need. Let's try this again. All right, so says num particles. Okay, it does seem to be generating them. I don't know if it's generating them incorrectly, but we get up to 20, 20, 20, 20, 20. And then line 146. Again, I think we end up with a bad index. So oldest particle. Oh, okay. This is going to get incremented past the size of the array. So we need to actually wrap back around. If source oldest particle equals source source max particles. Is that right? Then source, I mean, I actually probably should use a min or a max here, right? Source oldest particle equals 0. I think that is the reason for what we're seeing. Yeah, so at least it's not crashing. We're not rendering anything, but it's not, okay, well, it's crashing now. 132. System current time is greater than equal to system source next particle time. Is that right? System update MSC. Use after free. Okay, so how did I end up freeing that? It shouldn't have been freed. Ah, damn. Okay. I see. Problem we have here is that there's no way for the garbage collector to use the particle system as a GC route to then walk to the individual systems and mark those during the GC phase. So apparently what happened is the garbage collector ran and it collected all of the particle sources, and then it's no longer, it's been freed already. So some of the stuff that I need to implement in in mesh is coming back to bite me now. Let's at least see if we can render some particles first, and then we'll deal with the GC issue. I didn't see anything rendering, but it's probably because we're not updating the origin of the particle system every frame. So mesh GC hacking, maybe not today. We'll see. We only got about 15-20 minutes left here. All right, so let's add another couple functions here. Particle system, well, one's good enough. Particle system origin set. So we want to set the origin position. Do I have... yeah. You can call that origin X, origin Y. Actually, it does sound better. And then we look for system pos. Yeah, there's only those two places. Origin X, origin Y. Actually, I think whenever I create make system, I'm not initializing those values. So that would be another problem here. So origin X, probably need a way to pre-initialize those values, but that's okay. So then back in player.msc, before we call particle system update, we need to update the origin set, and that should just be the player X. Let's just say player X and player Y positions, player Y. So when we set that, then we should be able to get particles coming from where the player is. Hopefully that shows us something. Okay, something's broken. Let me catch that really quick. Undeclared. Okay, let me go back to particle.c. What did I do wrong? Oh, I never even implemented the function. Particle system origin set. Let me grab this. Okay, and then we need to get... oh, we need the system as a parameter as well. So if I go back to player origin set, I need to give the system. So let's just steal that really quick. Delete that. We can do it that way. So now, if I go back to particle.c, system star, steal that. Actually, go back. Steal that. Put it right here. So what I need is double. I have those as floats. Probably should change that, but let's just do this. Float. No. Don't need to do that. First of all, grab the system. Then system origin X, args1, args2. Okay, so that should be good enough. Probably need to put some args. Yeah, exactly. Alejandro is ahead of me here. Arg count, come on, arg count. Where are we at? There we are. I haven't been adding those in. Obviously I should. So, oh, and I don't have the, I really need helper functions for this. How many times have I said that? Arg count. Because this needs to stay up to date. Okay, here we go. Origin set, I called it. Particle system origin set. Origin set. Okay, let's run that now. Compiler's happy. I don't see any particles rendering. And then it crashes eventually, which is fine. Let's take those print statements out. So num particles, let's just hide it for a second. Okay, so render. Should I just print whether we're rendering or not? Okay, so the render function is being called. So num sources. Did I set that? Yeah. And then for each particle, let's say printf render particle D. And then J. So sources I. All right, so we are rendering the particles every frame, it seems, or we're trying to at least. So I wonder why it doesn't show up Let's actually render or put out the position. That would be helpful, I think, to see if what we're writing is a valid value. So maybe we can say particle pos x, particle pos y, like that. Yeah, that seems like legitimate positions. Now, is the color wrong? I wonder. So we can also do the color. Particle color RGB. Just doing a little bit of debugging here. That was only for the system. Okay, so Ah, okay, that's fine. I think these values are correct. So what's the problem? Particle size. We haven't looked at particle size yet. Maybe that's a problem. It's too small. So let's take a look at size. I really should use a debugger for stuff like this, but you know. Aha. Size is wrong. That explains it. So now, let's say size. Source size, particle factor next value, source size. What did I put in player to MSC for that? Is alpha correct? Alpha is probably fine. Because in the RGB function that I'm using in the mesh code, it sets the alpha channel to 255 or 1, basically. Size. 7 or 10. So why is it giving me a bogus value for that? Particle.c, particle size, factor next size. All right, so let me print this out. Printf created particle size. Oh, wait. Size is what? Okay. It's a float still. So particle size. Particle factor next value, source size. Let me just double check I'm doing things right here. Okay, size is there. Then when I read size, it's right here. Okay, max particles, geometry, color, then size. And let me make sure that in the particle code is still in that order. Particles, geometry, color, size. Okay. And then in player to MSC, I'm saying size could be 7 to 10 pixels. Let's just double check that. All right, so now if I go back up here. Okay, so we created the particle and the size is 0 then. So something else is wrong. I think we're really close though. We may see some particles flying in just a second, which would be great. Create particle size. Need to throw a little new line on that. Let me write what the factor has in it, because something here is incorrect. So system size dot min, system size dot max. I think that should do it, right? Whoa. System has no member named size. Does it? It does. Source. I'm wrong. Okay, so where's source? Do I have a variable for that? Yeah. Excuse me. So that would be source. All right. 0, 0. That does not make any sense. Something's wrong. So what about whenever I create it? So if I go up to make source, after I read in the size, yeah. Particle size 0, 0 still. So let's see. Is const printf before read. So I'm going to write out that if it was const here. So printf it's const. Wrong. Alright, so factor max. We already got the min. Hold on a second. Did I do something wrong? Oh, wait. Is it because they're integers? Nah, it can't be. Min of 0. How's that possible? Let's do I didn't update the value of I for is number. Where was that? Particle index plus 1. I think it's right. Oh, whoa, whoa, whoa. That's wrong. Oh, boy. Okay, this is bugged out. Okay. So, I did this wrong. So, if it is a const, I need to pull the car in the cdr. So, as number min car, that was enough to bring my brain out of a funk. Is number. Now, hold on. Yeah, okay. So I was wrong about how this is supposed to work, period. This is not needed. Not like I'm doing it right now. So as number min cdr. No, hold on. It's not a const. It's a list with 2 values. Okay, so that's just the way I'm representing this. Cdr car. As const. This is really assuming a lot, so I need to do some error checking here. To do, make sure we're dealing with a list of 2 numbers. All right. So as number min car. I think this should do it, because if it's a const and we want to pull, oh wait, I need to as const. Come on now. Min, and then pull the car out of that. Then here, as const min, but we also need to do as const on the cdr as well, and then get the car off that. Need to update the index. Yes, you're right. So basically, I just need to do that. Yeah, okay. So maybe the way I implemented this is just wrong to begin with. I don't need to have index be... Well, no, I do need to do that. Do I? No. Anyway. We'll leave it as it is for now. To do remove index pointer design not needed. Since index always increments by 1. Okay. So is const min, as number as const min car, as const. That seems correct. Let's try it now. Okay. Oh, I see something rendering up here, but I think it's not showing up right. Right at 0, 0. All right, so we do have particle sizes being loaded in. The sizes are being represented correctly. Particle size is being read correctly. Okay. So we can take this out. We can take this out. But we still do want to see what the position is, because I'm not sure exactly what the position is on those. Particle pos x, particle pos y. I think we're very close here. Okay, so it's very small values. And that's excuse me, that's because I'm not actually hold on, wait. Let me also see origin set. Something's wrong here. Set origin. System origin X. Come on. Origin Y. I want to take a look at what that value is. $600, $420. Now, what we're getting doesn't make any sense. But I think... Okay. Okay, there's something I missed. There's something I missed for sure. So, did I consider the player position? This is what I've done. When I'm setting the origin, it is the player position, but there's something else wrong here. I think I'm creating all the particles at once whenever the position is still 0. Maybe. Something is very wrong. Update. So update, what? Update. I think that I'm not managing. Actually, here's what I'll do. Printf next particle time, because I think we're creating too many particles too fast. Source next particle time. Okay, seems fairly reasonable, I think. But when I'm rendering particles, I'm not actually checking if the particle's alive. Am I? Num particles. Let's just do this. I think I had a line like this already, but let's double check it. I'm a little bit skeptical at the moment. Okay, rendering 2 particles, rendering 3 particles. That did seem correct. However, okay, that looks good. Update the particle position plus player's position. When I create them, that's what I'm doing. Or at least that's what I think I'm doing. Okay, so this is good. This is good. So when I spawn the particle, I also need to check the position X, position Y. Something is not right. Let's do FF. Particle pos X. All right, let's do that now. Create new particle pos. The position looks good to me. So why is it not rendering at the right position? Because I see something up here. Uh-oh, that was too fast. Yeah, it's not calculating the right position for sure. Let's see. I mean, we're almost there. It's so close. So in the render function, I'm saying where I'm rendering it. And I see where I'm setting the value. So let's actually check that. Yeah, why is it like that? Doesn't make any sense. Oh, hold on. The update function, am I screwing it up? Ah, did not plus equals that. That's why. Okay, check this out. Okay, so stuff is happening. They're not moving. Why are they not moving? Particle time left. Okay. I don't mind the crashing so much. So let's take out render particle. I don't want to see that printed anymore. But I do want to see in the update frame. If the particle is, or what the time left on particle is. So printf particle time left. Let's see. And then particle time left. Yeah, I see. Okay, let me just let it go for a little bit longer. Okay, I see some negatives in there. So it is being subtracted. That's interesting. Maybe the movement, the velocity that I'm giving it is not fast enough. So how about if I go back to player.msc? Oh, yeah, that's definitely not fast enough. It needs to be like, let's say, minus 200 versus positive 200. Let's call that 80 and 100. Let's see what that looks like. Okay, that's something. Not perfect. And it doesn't run long enough to see what happens to it. And they stop. So I think that must be continuing to render them after they're dead. So let me actually go back and stop that. So render.c, particle.c, render right here. Let's make sure the particle is still alive first. If particle time left is greater than 0, then we'll just drop this right in here. They don't get deleted. Yeah. There they go. Okay. So at some point the code crashes, which is not so fun. Probably if I change that initial size too. It needs to be more than that. Let's see. Let's just adjust it a little bit and then we can call this done. All right, so size 7 to 10. Geometry, let's call that, well, what is the size of the player? Player size. Here's a value for this somewhere. I just want to see what the number is. Size is 80. Okay. Let's do geometry. So this says 30. Let me go with like 60. And we need to offset the origin. So yeah, I'm trying to think of like the right position to put the booster. And also, let me do this too. Just take a look. It's a little bit too high. Whoops. We're very close now. I mean, we've got it rendering. It's just, buggy. Compile. Okay, so interval, lifetime. I think we can make this shorter. So how about 2? I don't know. It goes way too wide. How about this? Maybe like a 75 to 75. I think it should also go faster. So 150 to 200. I don't know. That's cool. Also need to put the position right. So the origin setting, we need to offset this somehow. So the player X, that's like the origin position is like the center point. Does it look right? More or less. Okay, so what I need to do here is add player size divided by 2 to the player X position so that it gets put under the ship and not on top of the ship. Oh, what did I do? Yeah, that. Wrong. So I think that's more or less correct, but we also need to subtract the... Yes, kill it, kill it. All right, last tweak, and then we're done. We don't have the ability to reference the size of the source. So let's actually make the geometry the same as the player size. It's not accurate, but it's fine. Whoa. I think I should subtract that, actually. Player size. Let's subtract the X position, right? Weird. Whoa. That was strange. Okay, so player size. Oh, no, wrong. We need to switch the order of that. All right. And the last thing I wanted to do... Okay, that looks much better. I wanted to move it around a little bit. Here, let's do this. Yeah, cool. Hey, it works. So last thing also, let's render the ship on top of the particles because we don't want the particles to be rendering on top of the ship. It doesn't make sense. And then I think this is the deal here. There we go. Should I shorten that generation time, make it more particles? How about instead of 20 particles, it could be 40? Needs to be faster. It's half a second. Oh, I did that wrong anyway. This is going to be really fast. Ooh, no, wrong. That was the wrong one to mess with. How about that? Yeah, something like that. Cool. It needs some tweaking, for sure. And then, what was it? Particle time left. Let's just take all these printfs out now. Okay, I think that's it. So I'm going to check this code in after the stream is over, and then we can continue working on this potentially next week to just try to polish it up some and fix the GC issues, and then add it to some other things in the game to make the game look a little bit cooler. But I think we did a pretty good job of getting something working today. We could definitely work that out later. Alejandro asked, why is it crashing? It's crashing because of the garbage collector. The garbage collector is prematurely deleting the sources. I just need to change something in Mesh that makes it possible for these natively allocated objects to participate in the marking phase of the garbage collection. So anyway, thanks everybody for being here today. I really appreciate it. Thank you specifically to Alejandro for all the very useful inputs on the code we've been writing. And until next time, not happy hacking. Keep it creative. We'll see you. Thanks.